this presentation, we're going to explore algorithms further. We're going to look at algorithms applied to two separate problems. As we already know, algorithms are a set of instructions that can be used repeatedly to solve a problem or complete a task. As your problem gets bigger, the need for a good algorithm grows too, because you need a systematic way to solve the bigger problem. We're going to examine two simple problems, counting and mazes. Okay, counting, something we all know how to do. We're going to look at three counting problems: counting students in your class, counting students in your school, and counting all the high school students in your state. Counting students in your class is really easy. I mean, your teacher can go around and count the students, or the students can count off one at a time. Now we can write a bit of pseudocode. That's code written in English, not in a specific computer programming language. So here's how the pseudocode would look for counting students in a class. You would set the variable class count to be 0. While there are students still left in your class to count, you would set the variable class count to class count plus 1. That's a really easy problem. Now, counting students in the school gets to be a little harder. You could use sort of a brute force method and gather all the students together and line them up and have someone go down the line counting them, or have them count off one at a time. But that would probably take quite a long time. Another method is to use divide and conquer. Divide and conquer is an algorithmic principle which breaks the problem down into smaller pieces and then solves it. So, one way to use divide and conquer to count the students in your school would be to leave the students in the classrooms. Have each classroom count their students, creating a variable for that classroom called class count. Then you would add all the class counts together and get a number called school count. The pseudocode for counting the students in your school looks something like this. The first part of the pseudocode would be the same as for the classroom count. So in each classroom, you'd set the class count to 0, and while there are students left in the class to count, you'd set the variable class count to class count plus 1. Then for the school, you would set the variable school count to 0. And while there are still classrooms left to count, you would go to each classroom, ask that class how many students are in it, ask them for their variable class count, and then set the school count to equal the school count plus that classroom's class count. And you would repeat this for all the classrooms in the school. At the end, your school count would be equal to the number of students in your school. Okay, now how many high school students are there in the state? This is an even harder problem. Well, obviously, you can't really line them up. You would have to use the divide and conquer approach. You'd have to have each school count their students. And at each school, you'd leave the students in their classroom and have each class count off their students, and then add the students from each of those classrooms to get the school count. Then you'd have the schools report their school count numbers, and for each school, you would add that school count to the state count. Let's look at the pseudocode. Now you'd notice the first two parts of the pseudocode are exactly the same as before. So for each classroom in each school, you'd set the class count to 0. Then, while there's still students left in that class to count, you would set the class count variable to class count plus 1. After you counted all the students in each classroom, then for that school, you'd set the school count to 0. And while there's still classrooms left to count, you would go to each classroom, ask that classroom how many students are in it, asking for its class count, and then you would set the school count to be school count plus class count. Then for the state, you would set the state count to be 0. And while there's still schools left to count, you would go to each school and ask them how many students are in that school, or ask them for their school count. Then you would set the state count to be the state count plus the school count. And you repeat that for all the schools in the state. Let's look at mazes. Here's a really simple maze. You don't actually need an algorithm to solve this maze. You'd start here, and wend your way around like this and come out over here. No algorithm required. On the other hand, perhaps you might need an algorithm for this one. What kind of algorithms exist for solving mazes? Well, actually, a number of algorithms exist for solving mazes, and we're going to talk about two here. The first one we're going to talk about is wall following. Now, this is good if you can't see the whole maze, and it works on simply connected mazes. So with wall following, you pick a wall, either the right wall or the left wall, and you keep following it, never changing which wall you're following. So in the diagram below, the diagram on the left is using the right wall follow. And as you can see, it's following the right wall all the way around till the end. The diagram on the right is using left wall follow, and it's following the left wall all the way around to the end. Here's the pseudocode for wall following. This pseudocode is for left wall following. First, you find the nearest wall on the left. Then, if you can turn left, do so and move forward. If you can't turn left, move forward if you can. But if you can't move forward, turn right and then move forward. And you would repeat that for every step that you take. Well, that's a little hard to understand verbally, so I found a video on YouTube for you to watch. Here's the reference for that video, and here's the video. The second approach we're going to look at for mazes is dead-end filling. This algorithm is good if you can see the whole maze or if your computer can see the whole maze. And what you do is find all the dead ends and then fill them in. And what you're left with is the solution to the maze. Now this works only if there are dead ends. Some mazes don't have any dead ends, and hence the dead-end filling method won't work. Here's the pseudocode for the dead-end filling algorithm. First, find all the dead ends. You'd scan the maze, identify the dead ends, which would have walls on 3 sides. And then you would remember where the dead ends are. Mark them in some way. Then you would go back and fill in the dead ends. So you would go to each dead end, and while there's not a junction, which has walls only on 2 sides, you'd fill in the maze. And what you'd have left is the solution to your maze problem. Again, I found another video on YouTube, and here's the reference for that video. And here's the video. So in summary, algorithms are sets of instructions that can be used to repeatedly solve a problem or complete a task. The bigger the problem, the more you need a systematic way to solve it. In this video, we examined 2 types of problems: counting problems, where we learned about the algorithmic principle of divide and conquer, and mazes, where we looked at 2 algorithms: wall following and dead-end filling. Thank you.